Hi, this is Chetan Garg, your mentor for today's session. Today we will discuss a beautiful number theory problem, and in fact, that is equivalent to a 5 marker problem in IOQM. But before discussing, let's see what we have at Vedantu for the next IOQM exam. So, are you not satisfied with your performance in IOQM 2021-2022 exam? If not, then get ready for the preparation of IOQM 2022-23 exam with a new approach, with a very different approach that haven't been offered yet. Here is the PRMO IOQM Prime batch. In this, we have almost doubled the classes compared to the last year, and with some new additions that haven't been offered till last year. The entire course is designed by Lohit sir, and the batch will be taken by me and Abhay sir. In this batch, we will start from very basics and then we'll take you to the highest level of IUQM. The batch is designed in such a way that every student, independent of his current grade or level, will understand the entire course and will perform definitely exceptionally well in IUQM exam. So these are the features of this batch. There will be 70 lectures and 15 tests, and there will be extra session for basics, and in fact we have assigned one extra session per week for basics such that each and every student can understand all the concepts of IUQM. There will be telegram doubt solving sessions, and there will also be video solutions for all the assignments that will be provided to you. Apart from assignments, there will also be video solutions for the test. The schedule will be like this. The batch is starting from April 4th. It will be 4 days a week, and the timing will be from 6:30 p.m. to 8 p.m. We have kept a very small genuine price for this course, such that only serious and maths lovers can participate in this course. The batch, initially it was designed for 20,000, but yes, we have kept it for 9,8999, and in fact you can get an additional 10% using the coupon CZPRO. The link to enroll in the batch is given in the description box. Kindly visit that and hurry up. There are very limited seats for this batch. The batch will be on first come first serve basis, right? So if you want to be a part of this batch, kindly click on the link that is given in the description, and you can apply CZPRO to get an additional 10% coupon discount, right? Now let's start with the question. So let's first see the question. What exactly is the question? So the question states that, can we place 0 to 9 10 digits in the 10 circles shown without repetition such that sum of the numbers in the vertices of each of the shaded triangles are equal, right? So basically what the question exactly states that we have 10 digits from 0 to 9, right? We need to place these digits in the 10 circles shown without repetition such that each shaded triangle, basically there are 6 shaded triangles, 1, 2, 3, 4, 5, 6, right? So sum of the vertices in each of these shaded triangles, that should be equal. So this is the question. So let's see how we can proceed with the question. So what exactly we can think? First of all, can we solve this question by hit and trial or by, let's say, brute force? Yes, surely we can, but then this question won't be called as a number theory gem, right? So there has to be some logical explanation. So what else we can do? We can make the equations, right? So let's first assign the variables to these circles, and let's try to make the equations, right? So let's assume these are the variables. So circle 1 will contain, let's say, a value and so on, right? And each shaded triangle, let's assume this should be x, some of these three elements should be x, some of these elements should be x, all the sums should be equal, right? So let's make the equations. So first equation should be a plus b plus c, that should be equals to, in fact, b plus d plus c, because each sum should be equal, right? That should be equal to d plus g plus h, right? That should be equals to e plus h plus I. That should be further equals to f plus I plus j, and that should be equals to c plus e plus f, and that they all should be equals to x. Practically there are a lot of variables and a lot of equations. This seems to be a little messy. We can proceed with this thing, but that is involving a lot of variables, right? 10 variables and further a value x. So let's try to think something else. Right? I think we are practically stuck here. Let's try to think something. There must be something that we are missing here. What we can think of? Let's see its symmetrical elements. Let's try to figure out whether the figure is symmetric about something or not. So what symmetrical elements we can think of? Basically all the vertices. Yes, all the vertices are symmetrical, right? As you can see, the entire figure, all the vertices are symmetrical, right? But can this fulfill our purpose? Or let's check some more symmetrical elements. The entire figure is basically symmetrical about the central element, right? Central number. So we can say that the entire figure can be rotated about the central number. Yes, that is one of the symmetry. But how can we figure it out? All the vertices are symmetrical. Yes, all the vertices are symmetrical, and entire figure is symmetrical about the central number. Can we use this in solving our question? I guess yes. Wait a minute, right? Let's consider these elements. If I consider the cornered three triangles and the central number, basically these three cornered triangles and the central number, the central circle, basically they are covering all the numbers exactly once. I repeat, these three cornered triangles and the central circle, they are covering all the numbers exactly once, right? And I know sum of all the numbers because I'm using only all the digits from 0 to 9, right? Let's do the calculations now. So what we have thought, let the equal sum to be x and the central number is c, right? So let's assume that sum of the triangles is x, that should be equal in each of the shaded triangle, and the central number is c, right? So basically what we are covering, let's make the equation 3x plus c, that should be equal to sum of all the digits, that is 0 plus 1 plus 2 equal sum, that is x, that has to be 15. So sum of these three shown pairs by red lines, that should be 15. The sum should be 15. But 15 can be written as a sum of two single digits in only two ways. We can write 15 as 7 plus 8, or we can write 15 as 9 plus 6, right? But our requirement is of three pairs, so practically central number cannot be 0, and hence we are left with only three cases, right? Now let's consider the other extremity. We have already considered the case when c is 0. Now let's consider the case when c is 9. Now the equation will become 3x plus 9 is 45. That simply implies
X is 12, right? Now consider these three triangles once again. These three triangles, right? Clearly, since the central number is 9 and the equal sum, that is x, that is 12, so sum of these three pairs shown by the red lines, sum of these three pairs should be 3, because x is 12 and central number is 9, so the sum of these three pairs, each pair should be equal to 3, right? But 3 can be written as a sum of two single digits in only two ways. We can write 3 as 1 plus 2, or we can write 3 as 0 plus 3. But again, our requirement is of 3 pairs, so practically central number cannot be 9, and hence we are left with only 2 cases. Now let's consider the case when C is 3, that is the central number. Let's consider when central number is 3. Now the equation will become 3x plus 3 equals 45. That means x is 40. Now let's consider these three triangles once again. These three triangles. We know thus x is, that is the equal sum, that is 14. Since central number is 3 and the equal sum x is 14, so sum of these three pairs, these three red pairs, each should be 11, right? And we know 11 can be written as a sum of two single digits in 4 ways. 11 can be written as 9 plus 2, or 8 plus 3, or 7 plus 4, or 6 plus 5. But since central number is already 3, so 11 equals to 8 plus 3 is not possible, as 3 is already used. So we are left with 3 pairs, and we also need exactly 3 pairs. So these 3 pairs will contain numbers 92, 74 and 65 in some order. Although we are not sure about the order, but yes, these 6 elements should be any one of the following 92, 74 or 65. That means the vertices should be the remaining digits 0, 1 and 8. That is, these 3 vertices, that they should be 0, 1 and 8. But the vertices are symmetrical about the central number. I hope you all remember that we have chosen the symmetrical elements, or the entire triangle can be rotated about the central number. So the vertices are practically symmetrical about the central number. That means 0, 1 and 8, they can be placed at the vertices in any order, any random order. The order won't matter because the elements are symmetrical about the central number. Right. So let's assume this is the order that we have selected, and 3 is obviously the central number. Now let's see how we can place the remaining 92, 74 and 65 digits. Alright, so let's first consider this digit 9. Obviously this x, which was the equal sum, that was equals to 14 in this case. So this sum should be 14, this should be 14, this should be 14, this should be 14, 14 and again 14. Now 9, we cannot place 9 over here, because then 9 plus 8 is 17, which is clearly greater than 14. Similarly, 9 cannot also be placed here. So there are 4 possibilities left for 9. Now let's consider what happens if we place 9 over here. So let's place 9 here. Clearly 9 was paired with 2, so this element has to be 2. Now the equal sum was 14. So to make the sum of the 3 elements in this triangle, this element has to be 12. But we cannot use a double digit number. So practically 9 is not possible here. And we have already rejected the cases when 9 is present here or in this circle. Now let's consider what happens when 9 is in this circle. So let's place 9 here. Clearly 9 was paired with 2, so 2 should be there. Now sum of this corner triangle, that should be 14. That means this element should be 11. But since this is a 2-digit number, so we cannot place 11 here. That simply implies 9 cannot be present in this circle. So we have rejected 4 possibilities for 9, these 2 circles and these 2 circles. Now let's place 9 in this circle. Now if 9 is here, right, So since 9 was paired with 2, so that has to be 2. 9 plus 3, 12 plus 2, that is 14. We also need this triangle to be 14. So 8 plus 2, 10, that should be 4. We also need this triangle to be 14. 4 plus 3 is 7. So here it should be 7. We also need this triangle, sum of the elements to be 14. This is 0, this is 7. So there should be 7 to make the sum 14. But since repetition was not allowed, but here we have used 7 twice, so practically 9 should not be present in this circle. Previously we have rejected 9 in these two circles and in these two circles. So only one possibility for 9 is left, that is this circle. Now let's see what happens if we place 9 here. Now since 9 was paired with 2, so 2 has to be here, making the sum to be equals to 14. Now we also require sum of the triangle, sum of these triangles to be 14. So in this circle 4 should be there. Again this triangle should also have the sum 14. So this should be 7. 7 plus 1 is 8. So that will make 6 here to make the sum 14. 6 plus 3 9. So here it should be 5 again to make the sum 14, and automatically this becomes 9 plus 5 plus 0 14. So this is one of the solution that we are looking for. But remember, still we are left with one more case. So when central number is 3, we have a unique solution. Obviously we will have the rotated versions, because I have previously told you that the entire figure is symmetrical about 0, 1 and 8. So we can place 0, 1 and 8 anywhere. This is a unique solution, and obviously with its some rotated versions. Now let's see what happens when C is 6, central number is 6. So now let's consider the case when C, that is the central number, that is 6. Now the equation will become 3x plus 6 will be 45. That will give you the value of x to be equals to 30. Now consider these three triangles once again. Now we know that the value of x is 13, and since the central number is 6 and the equal sum is 13, so sum of these three pairs, these three red pairs, sum of these three pairs should be practically 13 minus 6, that is 7. And we know that 7 can be written as a sum of two single digits in 4 ways. We can write 7 as 7 plus 0, or 6 plus 1, or 5 plus 2, or 4 plus 3. But since central number is already 6, so 7 equals to 6 plus 1 is not possible, as 6 is already used. So we are left with 3 pairs, and we also need 3 pairs. These 3 pairs, right? So we are left with only these 3 pairs. So these 3 pairs will contain the numbers 70, 52 and 43, obviously in some order. Again, at this point we do not know what should be the order, but yes, these are the elements which should be present in these 3 pairs. That simply means the vertices are the remaining left out digits, which are 1, 8 and 9. So these three vertices should be the digits 1, 8 and 9. But we know the vertices are symmetrical about the central number. We have already seen that the entire figure can be rotated about the central number, right? The vertices are symmetrical about the central number. That means 1, 8 and 9 can be placed at the vertices in any order, any random order. We can place these 1, 8 and 9 in these 3 vertices, in the corner vertices, in any order. Let's put it this way: 9 is at the top, 1 is at the bottom left, and 8 is at the bottom right. Now let's see, and see 6 obviously at the center. Now let's see how we can place the remaining digits 70, 52 and 43. We have already covered 9, 1, 6 and 8. Now let's see how we can place 70, 52 and 43 in this figure. Right, again let's since we know the sum, that is x, that was how much? That was 13, and this central number is 6. So let's think how we can place 7. We cannot place 7 in these two elements, because if we place 7 here, then the sum of these two elements will be 9 plus 7, that is 16, but we need sum to be 13. Sum cannot be greater than 13, equal sum. Once again, we cannot place 7 in these two triangles, because in that scenario the sum of these two elements will be 7 plus 8, that is 15, which is clearly greater than 13. So we are left with only two possibilities, either here or here. So let's consider the case when 7 is placed here. Now if 7 is here, 7 was clearly paired with 0, so 0 has to be there, right? Now we need the sum to be 13. This is clearly 13, this sum should be 13, that will make this to be equals to 5, and 5 was paired with 2, so that has to be 2, again making this sum to be equals to 13. Now we also require the sum to be 13, so 9 plus 2 11, so this element should be 2, but we have already used 2 and we cannot repeat 2 since repetition was not allowed, right? So practically 7 cannot be placed here. We have already rejected the cases when 7 is either of these 4 circles. So the only possibility left for 7 is this circle. Now let's consider the case when 7 is present in this circle. Since 7 was paired with 0, so 0 has to be there, making the sum of this triangle to be equals to 13. Now 0 is there, we want the sum to be equals to 13, so this element should be 4. And since 4 was paired with 3, so here it should be 3, and again making the sum of this triangle to be equals to 13. Now since here it is 3 and we require 13 here, so 8 plus 3 is 11, so here it should be 2. 2 was clearly paired with 5, so here it should be 5, again making this sum to be 13 and this sum to be 13. So this seems to be a perfect valid solution, making all initially shaded triangles sum to be equals to 13 and clearly using each of the digits exactly once, right? So finally we have two distinct solutions. Let's take a final look on these two solutions. First we have selected the central number. There were two feasible possibilities, feasible cases, 3 and 6, right? When the central number is 3 and 6. Then we found the vertices, right? They were 0, 1, 8 when the central number is 3, and they were 9, 1, 8 when the central number is 6. After that, at the final step, we have found the remaining elements, and they were in these order. So these are the two possible distinct solutions. Obviously, their rotated versions can be among the solutions, but yes, these are the two distinct solutions that are the possibilities for this number theory Gem. Right? Thank you for being in the session. We will meet you in the next session.